Thank you so much, and thank you everyone for taking time out of your busy week. I'm Marcus, nice to meet everyone, and I just met these fellow in the industry team members here today, and I'm really happy to get going on this talk today. So let's just start with an open question for everyone here today. One of the topics that we're talking about is security, and that's a topic that from everyone's background becomes important at a certain point in everyone's building career and also as a user of the blockchain. It comes from many different angles, and oftentimes we build security on top of legacy infrastructure. So with this legacy infrastructure, it comes with problems, and if you had to redesign this legacy infrastructure, what would you do today if you had to redesign it from the start?
Okay, I guess I can take this one. So yeah, we have AWS, which is, I think, legacy infrastructure. What compute is missing today is verifiability. It's very trust me, bro. Like a database is very trust me, bro, right? And the blockchain is replacing that. But not all compute can be done on a blockchain. So now we are using different levels of verifiability to different problems. Like we have T's, we have like some sort of consensus, we have ZK, and we have FHE. So these are like different levels of verifiability that you can apply to like different problems at different scale, right? So yeah, I would try to like make the internet more verifiable, because with AI, you don't know what to trust anymore. It's a real problem now.
And so verifiability options from the very beginning of development.
Exactly. Like internet started out with HTTP, and the banking couldn't happen because anyone could see your username and password because it's in clear text. We only got to banking and the boom of internet when we got HTTPS. So that was some form of like verifiability, right? Yeah.
Anything to add?
Yeah, so I think there's a difference between the product building and the security of the product building that is really seen in these situations where you have multi-systems connected and kind of depending one on each other, right? Because one of the things you can do when you build a product and you have some layers below you that are not very comfortable, a lot of times you can hide that. You can sort of like mitigate with like sugar on top, right? Like you basically make it look good, and in terms of the system as it looks and it operates, people don't even notice this. But you can't really do this for security, right? Because if you have a hole downstairs, like you cannot usually hide that hole, or like, and if you have some incompatibility between the layers that are being built, and some of them maybe were built like, 40 years ago, and some were built last year, but like it's a lot harder to like hide that. So like I think in that sense, I think it's something we just carry, right? It's not something that we can solve in an easy way, but I think that that's an important like difference in security.
I mean, I completely agree with them. Like it needs to be verifiable, and we need to have a quantitative and qualitative measure of security as well. I think he talked about various different ways. There are cryptographic, there is economic, there is hardware-based. There are, hardware is kind of a trust-based model of security as well. So there are many different ways in which you can call a system secure. And then who verifies it, right? Like, is all the interactions being verified? Is my product I'm just calling it secure? These are like different ways in which you can have to define security in order for us to actually talk about what it means.
As a follow-up on that, for the different types of verifiability that are available, are there any that you personally prefer in this? And today, let's just say today, it might change next week.
Yeah, I think it depends on what is the problem you're trying to solve, because you cannot use smart contracts for AI. An AI model takes a lot more compute. So I think one of the practical options is to use a TEE. So the NVIDIA GPUs have a built-in TEE, and they are iterating on it. So now you can have private AI inference if you use the NVIDIA Blackwell model. So you can your model can span multiple GPUs and still will be private. So they are like innovating on that side of things. When you are looking at DeFi, I think smart contracts are a great option, right? So it really depends on the problem you are trying to solve. If your problem is latency sensitive, then economic security makes sense because any form of compute takes time. Economic security is instant, right? Yeah, I would really think about it in terms of like how compute intensive is what I'm trying to solve, and
The cost,
yeah,
essentially.
exactly, and the cost, yeah.
I think that the conversation of whether you prefer ZK or MPC or FHE or TEs is kind of like a bit of panel talk, right? Because it's very high level, and you almost can assume that like it's one or the other. If I'm solving this problem, I'm using this. If I'm solving this problem, I'm using this. In reality, like just in Fireblocks, for example, right? We're famous as an MPC wallet, but our MPC wallet runs in a TE environment, and our MPC has ZK proofs in it and homomorphic encryption.
And I'm sure that decision was very specific to exactly what you guys are building and versus any other situation that you might be in.
Yeah, exactly. And it's also like eventually that decision is like really in the details, right? And then you start talking about like, is it the homomorphic encryption, fully homomorphic encryption, general purpose ZK, or like specific ZK? And a lot like, so like I think basically when like you actually build on these technologies, pretty quickly you find yourself borrowing from here, taking this, I want this, to eventually get to the exposure that you're basically happy enough with being protected. And I don't actually think happy enough.
Happy enough, right?
It's like, you know, like
I understand that.
We assume everything is eventually can be compromised. And that's why, by the way, you kind of want the layers, right? Like, and that's a lot what this gives you is the layers. You're saying, I like my MPC, but I really prefer it when it runs in a TE than when it runs in an open server, right? So like a lot of this is basically creating those layers. Yeah, so like eventually most actual systems, I think, use some combination that is sophisticated, not like basic as big building blocks.
I mean, completely agreed. I don't think we can add much. Like, there's defense is in depth, and you want to have as much security as possible. I would love to say like cryptographic security is the de facto standard of where we want to be. That is trust minimized, you trust the math, but it's not always possible. It's not always convenient. It's not always practical. You know, you have your limits on what you can do. You don't even want to do this sometimes. It's not about the cryptography of it. It's not about the computation of it, but just maybe, you know, someone wants to launch a token and they want economic security to be plugged in because they want value to their token holders. Like, and that's a valid point. I don't see a flaw in that. And if collectively that community is secure or honest, then the product is secure. And that's a fine enough trade-off to make.
Yeah. And it always goes back whenever you're going into a subject of this density. It depends. It depends. It depends on certain situations that anyone from their own worldview will come into based on the costs, and they must decide. And coming to that, the initial question was very much about if we could reinvent from the very beginning, what would we do? Well, we're not there. We can't do that. And if we are a new developer coming into blockchain space and having to consider security and all of the options in which you guys just discussed, what would be the first one to consider? As a beginner, just getting going with security? Is there one that you'd recommend to just get started, to become aware of the security options out there? And how would you recommend a new developer getting started to do this?
I always, whenever a developer comes and asks me, I say like pick the tooling which is closest to what you know. So if you're a Rust programmer, go and pick up SP1, RISC-0, any of these brevis, any of these ZK VMs which can make you run a Rust program inside ZK. Because TE is not that accessible. But if you have a TE-enabled machine, which probably almost always is there available right now in consumer-grade hardware, then if you can do that extra mile, turn on that, try to run a program. But it's more involved, and a beginner is not that used to it. But then there are many good partners like Fala Network and such who make it very easy. You have a Dockerized container, you go and run that inside a TE, And that's a tooling which, if it's close to you, if you know Docker, if you have the knack of running things inside cloud containers and orchestrating them, then go and use them. FHE and such are much more involved. And I don't assume that people will understand even the differences about the different types of homomorphic encryption that he mentioned. And that's why it's not important for them to understand that. The importance is to get their hands dirty, understand what are the trade-offs there, then go back to the problem that they are trying to solve, and then come back again to the security model that they want to offer to their users.
All right, well, I think we've gone over security really, really well. I want to go into, we also talked about integrity and making sure that we have the idea. I want to go into availability and understanding availability a little bit better. What does that word mean to you in this epoch of crypto? Because it meant something different a few years ago. What does it mean today for you guys?
Right, yeah. So we did data availability. We have a DA product, EigenDA. And now we have builders building on EigenAI and EigenCompute. So these products operate on some data. So AI operates on your prompts, and compute operates on your Docker images that you upload to EigenCompute, which runs in a TE, right? So when someone wants to verify that you are doing some compute, they need access to that data. So right now, most of our Docker containers is hosted on a Docker Hub. So that is a centralized storage system. And if that goes down, your data availability guarantees goes down. Yeah, so data availability systems like EigenDA, Avail, for example, they come into play. And I don't think they are just tied to blockchains. Availability is very important for verifiability. Yes. Yeah, and that is why we are building EigenDA, because it's not just for blockchain, it's for the AVSs, the compute, the AI, and all the products we build on
fuel.
The fuel, exactly, yeah. Yeah.
Anything to add?
Yeah, I think availability, as you mentioned in the end, right? It's a generic term. If you talk about security, generally speaking, security can be broken into liveness and safety. And in some systems, either safety or liveness or both are kind of compromised if the availability of a particular service or a particular data or a particular component is not there. So for example, I think we were talking to SpaceComputer here, and they're talking about launching, in satellites, they will have TEs and such. And one of their main concerns was availability of that particular satellite from a point that I'm trying to communicate. And that's a fair problem, right? And that also is a problem of availability. Just having, AWS, for example, we use a lot of these spot instances in various different AWS, DigitalOcean and such, and sometimes they're not available. So no matter how good my cryptography is, I cannot actually do a prover computation because some compute resource is not available, right? And so availability kind of compromises sometimes liveness, but sometimes safety as well, as in rollups. Yeah. And optimistic rollups particularly. So that is where availability becomes extremely important. And you have to talk about specific instances, specific security models, what is getting compromised, and what is meant to remain available for that security to not get compromised.
So 2 thoughts. First of all, much like security, availability is a team sport. Because you're only as available as your worst piece, right? So I think this is kind of like the challenge of a lot of systems in the ecosystem, that eventually nobody can do everything, but you're only as available in the processes you have on all of the pieces in the process, and a lot of times it's a lot of pieces. There's a lot of companies involved because there has been the full consolidation in the ecosystem so that a single company can basically solve everything. So that's just one part of it. The other one, I think there's a desire in our ecosystem to become the backbone of the financial ecosystem, right? Or at least it's a desire to some, right? Some people don't care about this, but to some there's a desire. And once you're in that realm, you need to start talking in 4 or 5 nines. Now, I don't know if anybody here worked on a 5.9 system. First of all, it's not fun. And second of all, it's really, really, really hard. So there's like exponential cost and in effort and just like money to be